To start building a theory of everything, we need to start with nothing and explore all of its unique properties. If this is the first video of mine on dimensionalism you are watching, I recommend that you start watching the Dimensionalism playlist from the beginning, as important disclosures are given in the last video to be forthright about my genuity and how I would appreciate building a discourse with mathematicians and physicists to make this theory and the parts within the best it can be. But the TLDW, if you don't want to go back and watch that video, is that I am not a physicist nor a mathematician, but I am both open to changing my mind about aspects of this theory and for a cordial discourse about this theory to occur between myself and physicists and mathematicians, or anyone who has a counter argument to anything that I put forth. But that's the way I've always been on my channel, so take what I say here with a skeptical grain of salt, and as always, think for yourself. So here we go. Have you ever tried to divide 1 by a really small number in a calculator? The number of zeros that you have before reaching your first one, including the 0 before the decimal, is equal to the number of zeros you will have trailing the 1 in the answer. So for some examples, 1 divided by 0.001 is equal to 1,000. 1 divided by 0.1 is equal to 10, and basically 1 divided by 1 times 10 to the negative version of any number will give you 1 times 10 to the positive version of that number. So let's take this to the next level. How many zeros can we put between 0.000 and its first 1? So for generalization purposes, and for closing in on what exactly counts as a finite number, we will say that we can put the number of zeros as it would require for the answer to the problem to give us the absolutely last finite number as the answer. It is basically the following expression. 1 divided by 1 times 10 to the negative aleph null plus 1 times 9.9 repeating, which would reduce to 9.9 repeating times 10 to the aleph null minus 1. Aleph null, for those of you who do not know, is the first transfinite infinity. It is basically the point where finite numbers are like no longer accessible and you are starting to count finite numbers, which are to start counting infinite numbers, I'm sorry. Like the 999 number that I described next to E is the last finite number, and one more than that would be too big to count as a definitive finite number and would be the first infinity. The reason why it is 9.9 repeating, and if it was instead equal to 10, that expression would be equal to aleph null. So it would not be a valid expression of a finite number. So I guess I need to go against the grain and explain that 9.9 repeating is actually not equal to 10. So let's start doing this. So we will say 9.999, and we will just skip on forward down to the last 9. And we will leave this spot open next to it and let that define the first infinite number, which we have no access to, and we will have no idea if it is a 0, 1, 2, or 9. We will have no idea if this number is any of these specifically, because they are part of infinite numbers and you cannot immediately define what is exactly beyond this point. Now, this number, using this strain of thinking, would be distinct from the 10 with 0, 0, 0, 0, 0, 0 before its aleph null place. So this number and this number are not equal to each other. And we would say that 9.99 repeating would be repeating only, and we can only be sure it is repeating only up until this point, because we are not 100% sure what happens after that. We can make an educated guess that it will continue to be 9, but we cannot be 100% sure. So in this line of thinking, 9.9 repeating is, in this instance, whenever you're being very, very, very as specific as you can in finite numbers, is not equal to 10. But for everyday counting purposes, we can say that 9.9 repeating is about equal to 10 because, well, there's only one decimal place separating the two. And whenever we're counting something with that minute amount of distance between them, saying they're equal is actually, it's not surprising that it is equal to 10. So what would happen if we moved this, let's say that instead of a 0 here, there was a 1. There was a 1 here, and this was 0. It'd be 0.00001. What would happen if we moved this 1 from there to there? It would be, well, we wouldn't know exactly what was there, so we would say that that is a true 0. That'd be a true expression of 0 whenever there's zeros all the way through the decimal points. That is basically the definition of an integer, something that has zeros all the way through until the last decimal point. Now, I could go on about omega infinities that cannot be reached by any methods by any of the finite numbers. Like, for example, if I took this number right here and put a factorial next to it, I'm pretty sure that this number would be an omega infinity. But instead of going into that, I think it's time to go into like the main part of this video, which is, well, everything. So to divide by 0, we need a new 0. Or because as it appears right now, 2 has two simultaneously true states that we already use in mathematical expressions, which I call 0 the finite and 0 the infinite. 0 the finite is how we usually deal with 0 and everyday addition and subtraction. Like 2 plus 0 is equal to 2 minus 0 is equal to 2. It doesn't add or take away anything from the equation. You can say it's already always there in the equation. And if you were to buy 2 apples from a store that only had 2 apples, their inventory would hold a finite amount of 0 apples. Now, 0 the infinite is what I propose as a new way of thinking about 0. It can be expressed like an infinite abyss of nothingness. So, to go back to what I was doing here, instead of, let's say 0 the finite stops right there, but 0 the infinite, well, even though we don't know what happens after Aleph Null, there can be zeros that happen well on past infinity that we do not know about, that we cannot fathom the fullness of the infinite depth of the zero-ness of what is going on. It's a really zero. This infinite 0, we can multiply, and I say now divide, everything. Whenever we multiply everything instead of absolutely nothing, we multiply by 0, we would take away everything from the equation. If we divided by 0, we would gain everything in the equation, or rather, everything would be possible. So anything and everything quantitative and finite, which I designate as, let's see if I got it, 2 infinity symbols making an X out of each other, approximately like that, is what I use. So as I was telling you earlier, anything times 0 is equal to 0. You can put everything in here and it would be correct. You can put pi here. Pi times 0 is equal to 0. 42 times 0 is equal to 0. Negative googolplex times 0 is equal to 0. I guess to really clarify on this everything in this equation, everything can be defined as the power set of all single finite numbers. In other words, every finite number between the first negative and first positive transfinite infinities. We will not be able to compute the full set, considering that just between 0 and 1, and including 0 and 1, there will be an aleph null amount of decimal possibilities to consider. To consider the complete set of every real number, just this by itself will do. But if we want to include like imaginary numbers, we'll just put an I next to it to consider imaginary everything, because I times 0 is also equal to 0. So I just had to make a distinction between the everything of the things that happen in reality versus everything that can happen conceptually. If we put a positive side in front of this instead, it would consider all of every positive finite number, and a negative would obviously be the opposite. It would consider all of the negative finite numbers, which will be important in a little bit. For everything, we will say that is equal to all of the real numbers. And for imaginary everything, we will consider it to be all the complex numbers, quantitatively at least. So basically, what I'm saying is, even though computing everything may be impossible, defining its existence and its parameters is not impossible. So therefore, if we accept that anything and everything finite multiplied by 0 gives us 0, I say that there shouldn't be an exception to the rule of the division property of equivalence that says that we cannot divide by 0, because in essence, I just defined the equations that have long been considered undefined. Namely, 0 divided by 0 is equal to everything. Well, to see if this is accurate, all we have to do is pretend that it can be 42 pi negative 369. So we just multiply 0 on both sides, and we would always get a true equation of 0 equals 0 once you do that. I mean, in addition to that 0 divided by 0 is everything, we can also expand that 0 divided by anything is equal to 0. Just to be more specific on what exactly happens whenever 0 is in the numerator and anything finite is in the denominator. So, but that is not all that we have to consider. There are the inverses of this phenomena to consider. What is the inverse of 0? So as the title 0 the infinite implies, the answer is specifically a dipolar infinity. What I mean by a dipolar infinity is that a positive, if you put anything positive and you divide it by 0, you will get a positive infinity. And anything negative, oh gosh, divided by 0 will give you a negative infinity. And using the multiplication property of equivalence for these two equations, we would get the following two equations as well. Positive infinity times 0 would be equal to positive everything, and negative infinity times 0 would be equal to negative everything. I guess there's also the everything divided by infinity is equal, well, I guess it could be plus or minus infinity, would be equal to 0. Now, the logical implications for this last equation are already in part largely accepted and taught in schools. Under the guise of the equation I was taught personally, 1 divided by infinity equals 0. So just ask yourself this question. What is 2 divided by infinity? How about 100? What number could possibly be in the numerator to be divided an infinite number of times and the number would be greater than 0? Perhaps aleph null, the smallest infinity, could be in the numerator and give us a non-zero answer, such that aleph null divided by infinity, which is close to infinity divided by infinity, but it's the smallest infinity divided by infinity, would be equal to 0.000 in aleph null minus 1 amount of times, with the first one in the equation being the first number that is recognizable and definitive out of the equation. Lastly, for this section, we also need to consider the values of multiplying the same types of infinities, namely 0 times 0 equals 0, and infinity times infinity equals infinity. Doing the division property of equivalence for these two equations, we would then get the following answers that appear incorrect at first glance based off of these new definitions, namely 0 divided by 0 equals 0, and infinity divided by infinity equals infinity. The 0 equation is pretty easy to explain, as 0 is indeed part of the original power set of everything. In fact, it splits the positive from the negative. So 0 is part of the answer of 0 divided by 0, but it is not a complete one. It's like saying the answer to x in the equation 2x squared plus 6x minus 12 is x equals 2. It's a correct answer, but it's not the complete answer. X equals -5 is also an acceptable answer. And when dealing with infinities, there's a lot of finite numbers, infinity touches, on the way to infinite vector space. One would be correct in saying that there are an infinite amount of finite numbers before infinity's vector would even reach the smallest infinity. So in saying this, although everything itself contains every finite number, the quantity of those finite numbers would be infinite. Well, specifically it would be an aleph null to the power of 2 whole aleph nulls to consider the positive and the negative. Well, it wouldn't be a very good everything if absolutely everything that we could say exists didn't exist within it. It should be noted that dividing by 0 when using normal finite mathematics and measurements should still be avoided, as doing so could make any finite number equal to every other finite number, which would be incorrect. So, again, I say what I'm doing here is not very useful in finite mathematics. However, uses for defining everything could be useful in regards to infinities, as I have shown earlier in this video. Honestly, having a grand unified theory of everything and not having a good mathematical expression to designate everything would be kind of silly from my perspective. And making the symbol this way can help remind us that there are infinities that occur within everything finite. There just happens to be a simple math equation that I propose should be regarded as an acceptable definition to presuppose that everything exists in the first place. It practically begs the question, does everything exist in the first place? So let's take this to a philosophical sense. Let's assume for a second that everything does not exist. It could just be that you exist. As Immanuel Kant would argue, I think, therefore I am. So in line with that thought, I would argue that even if it was only you that existed, your existence would contain everything. Therefore, everything, in some form, exists. But personally, I'd rather stay humble and presuppose that I am just one minuscule part out of everything. If you like this video, if you like thinking about this kind of things, please do us a giddy and click on those like and subscribe buttons and join our fellow sea creatures who live in the Notion Ocean. Next time I'm going to share the research I did to determine the number of dimensions our reality holds. And until next time, kumbaya, mother duckers.